Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry related to finding out the direction cosines of normal vector to a given plane, right? So let us start and let us see this problem. Here we have to find the direction cosines of the normal vector to the plane whose equation is 3x minus 4y plus 2z plus 3 is equal to 0, right? Okay, so now see, suppose we have a plane, right? Let us consider a rough diagram here, and suppose this is a plane pi whose equation is of this form, that is ax plus by plus cz plus d is equal to 0, right? So first of all we are considering the general case, right? So an equation of this type, that is of first degree, and in the form ax plus by plus cz plus d is equal to 0, it always represents a plane, right? So here we are given the equation of a plane as 3x minus 4y plus 2z plus 3 is equal to 0, right? So this equation is of this form, right? So it represents a plane. Okay, so now we know that an important characteristic of a plane is its normal vector, right? So every plane is associated with a normal vector. So let us draw a normal vector like this, right? So this is denoted as vector n, and this is the normal vector to this plane pi, right? Now this normal vector, the direction ratios of the normal vector are given by the coefficients of x, y, and z, right? So always remember that the direction ratios of the normal vector are given by the coefficients of x, y, and z in the equation of the plane, right? So if the equation of the plane is not in this form, then first of all we convert or we modify the equation to this standard form, right? So the drs of the normal vector are given by a, b, and c, right? So now if we compare this equation with this equation, then the direction ratios can be written as 3, then we have minus 4, and then we have 2, right? So the direction ratios of this normal vector are 3, minus 4, and 2. Now our aim is to find out the direction cosines of this normal vector, right? So we know a well-known relation between direction cosines and direction ratios, right? So suppose the direction cosines of normal vector are denoted by say L, M, and N, right? Then the relation between the direction ratios A, B, C and L, M, N is given by these relations, that is L is equal to A over square root of A square plus B square plus C square. Then M is given by B over square root of A square plus B square plus C square, and then N is given by C divided by square root of A square plus B square plus C square, right? So this is the relation between the direction cosines and the direction ratios. So now let us first find this quantity, that is square root of a square plus b square plus c square. So this is equal to square root of 3 square, then we have minus 4 square, and then we have 2 square, right? So a, b, c, we can substitute the values of a, b, and c, right? So now we have 9 here, here we have 16, and here we have 4. So this is square root of 29, right? So now the value of n L is given by a over square root of a square plus b square plus c square. So a is 3. So we have 3 over square root of 29, and m is b over this quantity. So we have minus 4 over square root of 29, and n is equal to 2 over square root of 29, right? So the direction cosines of the normal vector are given by 3 over root 29. Then we have minus 4 over root 29, and then 2 over root 29, right? And moreover, we also know a well-known relation in direction cosines, that the sum of the squares of the direction cosines is always equal to 1, right? So this is how we can find out the direction cosines of normal vector to a plane when the direction ratios of the normal vector are given.